of the question, which is pretty simple, but many of the students lose marks over here because of this silly mistake. Okay, so let us do it. A skydiver is falling at a terminal speed. Okay, first of all, we should understand what is terminal speed. So whenever any object falls down, of course, weight is acting downward, right? Now, because you are moving through air, so air also applies a resistive force on you, which is called air drag, which acts upward. Okay, and in a situation when the air drag is equal to the weight, the net force on you becomes zero because they cancel each other out. Net force becomes zero means m into a zero, right? The force is the product of mass and acceleration. Mass of the skydiver is definitely not zero. That means the net acceleration is zero, and net acceleration not is zero means you move with a constant velocity. That means you're not accelerated. That doesn't mean you are at rest. Means you're moving with constant velocity. Cool. So now what happens when she opens her parachute? What are the direction of her velocity vector and the direction of her acceleration vector before she reaches the new terminal speed? Cool. So now what is happening? She is already at terminal speed, and then she is opening up her parachute. So terminal speed means, okay, like what is happening? The net force is zero, right? Terminals at terminal velocity, and you see that there is of course no acceleration, and the velocity vector is downward because the skydiver is moving down, right? But what happens now once she suddenly opens the parachute? What happens? What changes when she opens the parachute? Air resistance suddenly increases because the area increases, right? It's more air particle hits the parachute, so the drag increases suddenly. Okay, that means now air resistance, which was earlier equal to the weight, you see earlier when she was on the terminal speed, air resistance and weight were equal to each other. But now your air resistance suddenly increases a lot, okay, and your weight is same as it was early, right? So in that case you get a net force upward. Okay, so your direction of acceleration gets upward, so your direction of acceleration vector gets upward. So these two options are wrong anyways. Okay, cool. But though, now this is very important, this is where students make mistake. Even though the acceleration changes the direction, velocity does not change direction instantly. She is still moving downward. Yeah, of course, she is slowing down. Okay, then it will start, then she will start moving up if acceleration if the air drag keeps on increasing. But she suddenly doesn't start moving up, she is still falling down, so the direction of velocity vector will still be downward. Okay, so option A is wrong. Okay, so option C is the only correct option, where the direction of velocity vector is down and the direction of acceleration vector is upward. I hope you have understood.